Friday was that we talked about how to find an inverse. So switch the x to y, solve the equation for y. And this problem is referencing up above when we did those 6 problems that are at the top of the paper. And it says that we are given the function f of x is x cubed, g of x is the cubed root of x. And it says we found in part C, which you should have because you all did those problems at the top of your page, that g and f were inverses of each other, right? You were given f, or you were given one of them, and that you found the other was the inverse. So now here's what we're going to do. I told 8th period this on Friday, and they were not happy with me, but we're going to do a proof. Okay? I know you hear proof, and you get super excited. Don't freak out. It's not a 2-column proof. We are never going to do a 2-column proof. We're going to do a mathematical, an algebraic proof. So what an algebraic proof is it's basically you're just doing some algebra. You don't have to write given. You don't have to write a sentence. You don't have to do a T-chart, whatever it is. You just have to do some algebra. Now, we're going to discover something here, so I'm not going to tell you what we're proving yet, but, well, I am. We're going to prove that these are inverses, right? F and G are inverses. So we're going to do 2 things. We're going to do this guy. What does that even say? F of G. Yeah, this is composition. So we're going to do a composition of functions. F of G of x, and then we're going to do G of f of x, and we're going to figure out what happens. Okay, so let's do, this is our proof, right? I know, I'm saying that, I shouldn't have even said that. Now you just turned off, but it's not bad, I promise. So let's talk about f of G of x. When I compose these functions, which one goes into the other? G goes into f. So you're going to take this cubed root of x and put it in for x into f. Okay. So let's see. How do I want to write this? Let's take our parentheses. We're going to take this cubed root of x. That goes in for x here, and then where do I put the cubed? Outside the parentheses. Well, what happens when I take the cubed root of x cubed? It cancels, and you just get what? X. All right, that's the result of the first composition. Now, I need to find g of f of x. So same kind of idea, but I'm going to take f and put it into g. So I'm going to take the cubed root of, what goes in for x here?
3x.
Not 3x, x cubed. Well, again, what happens with the cubed root and the x cubed? They cancel each other off, and you just get x. What's the result of both compositions? X. Okay. Something happened there. I'm not going to tell you what yet. Let's try another one. So now when I look at number 2, I have h of x is 1 over x, and I of x is 1 over x. This also was part I, or part from above, part whatever from above. You see the, I think, F from above. So we're going to find the composition again. H of I of x and I of h of x. So let's do that first one first. H of I of x. So we're going to put I into h. Okay, so we're going to take this 1 over x, and we're going to put it into h. So we'll have 1 over, yes, 1 over x. Now, when we divide by a fraction, we talked about this just a couple minutes ago with some of us. When you divide by a fraction, you actually end up having to multiply by the reciprocal. So you're really taking 1 times, what's the reciprocal of 1 over x? X over 1. Well, what's 1 times x over 1? Just x. Okay. Well, let's do the next one. We have I of h of x. Okay, so you're taking h this time to go into I. Well, it's going to look the same because h is 1 over x. So I have 1 over, I wrote that weird. 1 over x again. Well, since it's the same, what should you get as your answer? X. Well, again, what did you get for both compositions? You got x again. So we already know that these are inverses, right? You did those up above, those 6. What does it seem? What seems to happen? You get What answer do you get? X. So we've found that we can show or prove that two functions are inverses if and only if. That's another geometry favorite thing, right? If and only if they're both compositions give you x. So basically if like f of g of x and g of f of x both equal x. I'm just using f and g as general functions here. But two functions are inverses is if you do two compositions, f of g and g of f, and you get x for both of them. Then they're inverses of each other. We did two functions that we already knew were inverses, but we're going to try it now with two functions that we don't know if they are inverses, and we have to choose. Okay? So flip your paper over. This is our last one today. We want to decide, we need to figure out if 2x plus 1 and x plus 1 over 2, if they are inverses of each other. So we need to do both compositions. We need to do w of z of x, and you need to do z of w of x. You must show both compositions. Don't give up after one or make a decision. You have to do both. So let's review this composition as well. Let's start with the first one. We're going to take z and put it into w for x. So I will start here with 2. Now instead of x, you're going to put your x plus 1 over 2, and then tack your 1 on the end. What do you want to do first here? What do you want to do? Distribute the 2. All right. We'll distribute the 2 just to the numerator. Remember, because this is a 2 over 1. So you multiply the numerators, multiply the denominators. So we'll get 2x plus 2 over 2 plus 1. Well, what happens next? You can divide it up. What's 2x over 2? X, what's 2 over 2? 1, and then I have another plus 1. Well, what do I end up getting as a result? X plus 2. All right, so right now you probably have an idea. Does it seem that these are inverses? No. It would be no, probably, because we should get an x here. But you should show the other one, because that's the only way to prove and to make sure that you didn't make a mistake. Because what if you get x over here, then you kind of have to figure out if you made a mistake somewhere. So let's try this composition. This time we're going to take w and put it into z. Okay. So we're going to take 2x plus 1, stick it in here to z. So let's see. Instead of x, we're going to have 2x plus 1, and then plus 1 more 1 on the numerator, all over 2. Well, what does the numerator simplify to be? 2x plus 2 over 2. Right? 2x over 2 is x. 2 over 2 is 1. All right, well, would you say that these two are inverses? No. All right, so these are not inverses. Do you think that it is okay that the results of our compositions are not the same? Or do you think they should be the same? I don't know. I heard both. I think it's fine. All right, it is fine. These do not need to be the same. So I'm saying that because I don't want you to freak out. Well, this is x plus 2 and that's x plus 1. They're not the same. Oh my gosh, I don't know what I did. It's okay that they are different. All right, they don't have to be the same result. Hopefully, you want them to both be x. But if they're not x, they're going to be two different things probably. Okay? All right, so that's how you prove if something is an inverse or not. Here's what we're going to do for the rest of the time. You have a little bit of homework. This is practice for your quiz tomorrow. You have not that many problems. 3 inverses. Find the inverse. And then 2 or 3, we have to verify, decide if they are inverses or not, doing the composition. The answers are right there on the bottom of your paper. I would check as you go. Call me over if you have an issue, but then your quiz tomorrow will be finding an inverse, graphing an inverse, and verifying it. All right, I'll come around and help you.